is Derek Demeter. I'm with the Emil Buehler Planetarium at Seminole State College up in Sanford, Florida. Just about 45 minutes. You can even take the sun rail straight up to Lake Mary and visit the planetarium. Hopefully, once this pandemic is over, we'll be able to reopen the planetarium and have you all out and experience some amazing programs. We do offer virtual programs as well, so you can always visit our website at www.seminolestate.edu/planet. And I'll also mention that at the very end of the program as well. But what I'm going to talk to you all today is about our amazing solar system. We're going to look at Earth's neighborhood, cruising the solar system. Now, of course, right in front of us here is our planet, my favorite planet in the solar system. If people have asked me, what's my favorite planet in the solar system? It's got to be Earth. Why? Well, it's no brainer. We live here. We are in a place of perfection for us human beings. We have all the air we can breathe. We have all the water we can drink, all the food we can eat, and everything that we need in our lives we have here on this planet. It is the perfect spaceship to visit the universe. But what we're going to do though today is we're going to talk about the other planets in our solar system and what unique aspects of those planets are and what future human exploration will happen in certain areas of our solar system and other things too. So let's go ahead and get started with the first planet in our solar system. Think about it right now in your head. See if you can think about which planet that is. I'll give you a few moments to think back in those days where you had to remember the planets in the solar system, and some of you probably already thinking in your head, well, Derek, there's 9 planets, but now there's only 8. What's going on here? Don't worry. At the very end of the program, we'll be visiting that final place in the solar system. We'll talk a little bit more about why things have changed over the years in regards to this area in the solar system. Do you have the name of the first planet yet? Well, if you said this planet, Mercury, you would be correct. Mercury is the first planet in our solar system. Now, when you look at Mercury here in the slide, you can see that it looks a lot like our moon, right? Well, you can probably definitely tell there's a lot of craters on the moon. There's a lot of craters on Mercury. And that actually gives us a clue to the age of the surface of Mercury. When you have objects that are heavily cratered in the solar system, that tells us something. The age of the surface of the planet. See, Earth doesn't have a lot of craters because we have volcanoes, we have plate tectonics that shift and move around stuff. Well, Mercury doesn't have all that. It's actually a very small planet. It's about the size of our moon. So it's really close to the size of our next celestial neighbor to us. But Mercury doesn't have plate tectonics. It doesn't have volcanoes. And so the surface of Mercury pretty much stays the same as it was when it first formed over 4.5 billion years ago. And those craters that we see on Mercury are mostly made up of very old craters during a time we call the Great Bombardment, a time when there was all this space debris floating around space. And many of these objects, including our own planet Earth, were hit by these little tiny rocky objects we call meteoroids, asteroids, and even cometary objects. Well, anyway, so Mercury is completely covered in these craters. And there's a new mission that's actually on its way to Mercury called Bepi Colombo. And the primary mission of Bepi Colombo is to really investigate how Mercury formed, how it developed, how the surface became the way it did. Was Mercury a much larger planet a long time ago, and that being so close to the sun, only about 30 million miles from the sun, did most of the surface get vaporized as it was cooling down? These are questions that Bepi Colombo are going to help answer more about the ancient history of this little tiny world in the solar system. Now, let me tell you something about being close to the sun. You probably imagine that being so close to the sun, again, only about 30 million miles, you're going to experience extreme temperatures, right? Well, you would be correct, but it's not like you think. You will have extreme heat on the side of the daytime. So the side facing the sun, like you see here, will reach up to 800 degrees. But here's the interesting thing. In the night, the temperature can drop down to minus 200 degrees. Without an atmosphere, All the heat that's radiating off the surface during the day will escape into space at night, dropping the temperatures down significantly. And that's what we have here at Mercury. But there's one impact crater on Mercury I want to share with you all, is this one here. You can actually see the outline of this large crater right there. You can see how it kind of makes this big, giant circle. Well, this is the Chlorus Basin. The Chlorus Basin is one of the largest impact craters in the solar system. Something massive hit Mercury a long time ago. It with so much force that there actually is an opposite. Basically, imagine hitting one side, maybe like think of a car. You hit a car or a piece of metal and it actually creates a bulge on the other side. That's exactly what happened. Where this impact crater occurred, on the opposite side of Mercury, there's actually a little bit of a bulge that actually sticks out from this impact energy transferred through the entire planet. This was a massive event. Well, this is called the Chlorus Basin, and the Chlorus Basin literally translates to heat basin or heat valley. And the temperatures that can be recorded here are up to 1,000 degrees, making it the hottest place in this entire solar system in one area. But it's not the hottest place on average in the solar system. Actually, that goes to another planet, which we'll talk about here in just a few moments. Now, one of the most interesting things about Mercury is that we thought for a long time that being so close in the solar system, there wouldn't be any traces of water on the planet. Well, recently with the Messenger spacecraft, which spent time exploring Mercury a few years ago, we discovered that in the north and southern pole regions of Mercury, there are traces and deposits of ice in those shadowed craters that do not see any light whatsoever. That's because Mercury is almost pretty much straight up and down, and it rotates straight up and down. It doesn't have a tilt like Earth. So these craters are heavily shadowed, and there's ice deposits on those areas. So we actually find that there's ice in these deposits on Mercury, which is very cool because for the longest time we thought water could not exist in these parts of the solar system, but we're constantly getting surprised and getting excited as we learn more about these tiny little worlds. All right, we're gonna leave Mercury next. And let's think about the next name of the planet that we're gonna visit right after Mercury. Do you have it? All right, if you said Venus, you would be correct. Venus is the second planet. Now, we're about 60 million miles from the sun. 60 million. Now, the scientists that saw Venus for the first time here, when they looked at Venus, they saw that Venus had this beautiful, rich atmosphere of clouds. In fact, you can't see the surface of Venus from space. Nowhere on the planet can you see the surface from space. It's completely covered in clouds. And the earliest astronomers thought that those clouds were similar to the clouds we find on Earth. These clouds are made up of water vapor and dust and things that we have just like Earth. Maybe it rains all the time. Maybe it's more tropical type world. But when we actually sent spacecraft to Venus and we actually really understood the composition of those clouds, we learned that the clouds of Venus are actually made up of sulfuric acid. This is stuff that we find in car batteries. This is stuff that is very dangerous to handle. You can actually burn your skin if you were to expose yourself to sulfuric acid. This is a dangerous thing to handle. And imagine the entire planet is covered in this vapor of sulfuric acid. Well, not only do we have sulfuric acid clouds, but the atmosphere of Venus is completely different than Earth. It does have an atmosphere, because we can see the clouds and stuff. Earth's atmosphere is primarily made up of nitrogen, oxygen, a little bit of carbon dioxide, and just a few trace other gases. But it's primarily nitrogen and oxygen. And that's actually what we breathe in. We call it air. That's what we breathe in. And that pretty much allows us to stay, alive, right? Well, the atmosphere of Venus is 96% carbon dioxide. 96% carbon dioxide. So, carbon dioxide is this giant greenhouse gas. It actually absorbs heat and doesn't release it. It's kind of like a blanket for a planet. It actually absorbs heat, traps heat, keeps the planet warm. Well, Earth only has 0.04% carbon dioxide right now. It is going up a little bit because of our emissions that we release in the atmosphere. But imagine, 0.04% does heat up the planet a lot. And that's what allows Earth to stay nice and relatively warm. But imagine 96% carbon dioxide. What happens at that point? Well, the temperature on Venus, day and night, yes, you heard me right, day and night, well, is about 800 degrees, day and night on Venus. So you have extreme temperatures on Venus. And this is day and night, so there's no escape to this extreme heat. Well, we sent a spacecraft to Venus called Magellan. And Magellan had the opportunity to send radio waves down to the surface of Venus. Well, this is what we have here. This is a surface map of Venus by radio waves. So this is what you can see here, and you can see that Venus lacks any plant life. It lacks any life at all. In fact, it's just this barren wasteland of rock. And the rock gets so hot that it actually glows red at night. This is a dangerous place. There's even volcanoes on Venus here. We can see one of those volcanoes. Interestingly, though, Venus doesn't have plate tectonics. It doesn't have the same interactions that occur here on Earth. So these volcanoes are still, we don't really know for sure what is causing these volcanoes. It could be the pressure, the amount of atmospheric pressure pushing down the surface that's creating a lot of superheated rock. We don't really know. We're still trying to figure out why Venus has volcanoes like Earth, but lacks the more internal stuff that occurs deep inside the planet. So far we've been to 2 planets that basically don't have any chance for human exploration. These planets are just too hot, they're too dangerous. These are places where, humans cannot explore. Of course, the next planet from Venus, about 93 million miles away, is us, Earth. But we don't need to go there just yet. We don't need to stop there yet. We still got plenty of more stuff to explore in our solar system. And let's think about where we're going to go next. But again, think about in your head right now, I'll give you a few moments to think about the name of our next planet. And if you guessed this one, you're right. This is the planet Mars. Now, Mars is the next destination for human space exploration. Well, technically. Right now, we're actually building, NASA is actually building a lot of infrastructure right now for a new program called Artemis. And Artemis is this really, really cool rocket program that will eventually send humans back to the moon. So this is going to be really exciting. Not only are we going to have astronauts back on the moon, we're going to have the first female astronaut on the moon, which is really exciting. But eventually, all the technology is going to be developed by Artemis will be used for a longer mission to Mars. Now, it takes about 3 to 4 days to get to the moon. But to go to Mars, you have to wait every 2 years until the alignment of both Earth and Mars are at their closest. See, Earth travels around the sun faster than Mars does. And so we have to wait about 2 years for Earth and Mars to catch up to each other, and then we can finally launch a rocket. Well, even at that distance, the closest we are to Mars, it will take about 9 months to get to Mars. So think about this. You have to be with a group of astronauts for up to 9 months in a structure that could be no bigger than a small office building. But right now we're actually working on deep space vessel type structures that will basically allow, for habitats and things like that, so the astronauts aren't just cramped in this one little tiny capsule like they did with the moon landing. So it's going to be a totally different event, totally different mission. It's going to be an exciting thing. Now the question is, when is this going to happen? Well, probably within the next couple of decades, but NASA is always competing for funding, and we'll see what happens. Of course, with the pandemic and things have happened with that, this might get prolonged even longer. But at some point, we are going to go to Mars. That's the next step for human space exploration. And one of the things that I get people ask me all the time is why? Why do we want to go to Mars? What's the big deal about it? Well, for one, scientific reasoning. We can do a lot more with humans on the surface than we can with robots. As cool and amazing as the robots are, they're limited on mobility, where they can go, how fast they can collect the data. Humans do a lot more efficiently. The other thing is that just it's human nature to continue to explore. But the most important thing is actually what's going to benefit us here on Earth. The technologies that are going to be developed by the space program are going to trickle down to us here on Earth. For example, during the Apollo missions, microprocessors, smoke detectors, cordless power tools. Those are just the few of the many technologies that came out during the Apollo program that help us here on Earth. Without the Apollo program, we wouldn't have our phones, tablets, laptops, computers. We wouldn't have all the things that we enjoy using today. So you can thank the space program for that. If you like to do TikTok dances, or if you like to go on Instagram, you can thank the Apollo program for that. Basically, anything you love and enjoy in life right now when it comes to technology probably came from the space program. So again, going there will help us here on Earth and also tackle a lot of the issues with climate change, with energy issues, things like that. Well, here we have Mars. And Mars is a totally different world than Earth. Even though it's an explorable world, it doesn't have an atmosphere, very little. It does have an atmosphere, it's just very, very thin. We'll have to wear spacesuits. It doesn't have a magnetic field. Earth has one, and it actually protects us from this solar radiation that shoots off from the sun all the time. So we're going to actually have to build habitats underneath the surface just to protect ourselves from the radiation from the sun. So those astronauts, those first human explorers, are going to have a hard time. It's not going to be as easy as it would be exploring here on Earth. We have large structures on Mars. We have this thing called the Valles Marineris. This is a large rift valley on the surface of Mars. We also have other things on Mars, like the Olympus Mons. Olympus Mons is the largest volcano in the solar system. Now, a long time ago, Mars was much more like Earth. It had a really thick atmosphere. It had liquid water on the surface. It had volcanoes. This is an extinct volcano, which means that this volcano no longer erupts. This is an ancient volcano. By the way, this volcano is the size of Florida. And that hole that you see in the center there, it's called the caldera, is the size of the entire area of central Florida. You could travel from Sanford down to Kissimmee, basically through that large caldera. So this is a massive volcano. Well, how do we know that Mars was a hotter, wetter world? Well, we've sent robots to Mars. This is the Curiosity rover. The Curiosity rover is still there today, constantly exploring some new insight on Mars. Curiosity rover, it's about the size of a small car, has been exploring an area known as Gale Crater. And this crater is actually home to an ancient lake bed or seabed. And we've actually found clay deposits. We found beach erosion. We found all the signs and evidence that you need to basically support that there was once flowing liquid water on the surface. And this is really exciting. We now know that Mars is a hotter world. We know that it had a thick atmosphere. In fact, the reason why Mars is red is because of the oxidation of the rocks. There was once a thick level of oxygen in the atmosphere to cause all those rocks and dust to turn rusty. So this is really exciting. We now know a long time ago Mars was a much Earth-like world. But there actually are some deposits of water on Mars. In fact, the Phoenix lander, which was a lander that landed on Mars back in the late 2000s, actually discovered deposits of frozen ice underneath the surface of Mars. This is one of the polar ice caps on Mars. And underneath a layer of what we call dry ice, which is frozen carbon dioxide, underneath that is frozen water. So we actually found out that Mars actually has frozen water underneath the surface, which is really exciting because if the water still exists today, it could very possibly be that life, if it got started on Mars a long time ago, could have adapted to live underground in these deposits of ice. So we'll see what happens. So this is very, very, very exciting. Now, Mars has moons. Mercury and Venus didn't have any moons, but Mars does have moons. This one here is called Phobos. And Phobos and the next one here, Deimos, are very tiny little worlds. We actually now know that these were most likely captured asteroids. Not too far from Mars is the asteroid field, a conglomerate of millions of tiny chunks of rock that are basically orbiting between Mars and our next planet. And at some point, these asteroids got knocked out of the asteroid belt, and Mars captured them. So, believe it or not, both of these right here could fit inside northern Osceola County. That's how small these moons are. And they're actually getting pulled into Mars. So eventually, at some point, the moons of Mars will actually fall down to the surface and basically collide with the surface. So it's kind of an interesting thing here. Now, the latest mission to Mars is the Perseverance mission. This just landed this past year here in 2020. And landed successfully this past year in February. It launched in late July or early August, but it landed safely on Mars back in February. Well, the Perseverance spacecraft, also Rover, is going to do something different than what Curiosity did. It's going to be a fossil hunter. It landed in an area known as Jezero Crater, which is possibly home to deposits of potential ancient life. Fossils of ancient life, or maybe ingredients for ancient life, can be found here. And it also has a companion, Ingenuity, that will actually be flying around the surface looking for places where Perseverance could go explore. So it could be very soon where this rover will be able to find signs of ancient life. It's also going to collect samples, and eventually another mission is going to arrive to Mars to bring those samples back to Earth. So it won't be a matter of time until we actually have genuine Mars rocks here on Earth, which is really, really cool. All right, now we're going to talk about a whole different part of our solar system. We're now going to leave the inner solar system, which are basically rocky planets. And now we're going to go ahead and make our way to the next groups of planets. We call them gas giants. These are massive planets. And this is Jupiter. Jupiter is the largest planet in our solar system. You can fit over, 1,000 Earths. 1,000 Earths inside Jupiter. That's a big planet. But what Jupiter is made up of is primarily hydrogen. It's basically the most abundant element in the universe. It's the most abundant element in the universe. And this is pretty much what this thing is here. Now, Jupiter is actually the oldest planet in our solar system. It actually formed first. They all formed around 4.5 billion years, but Jupiter was the first one to form. And if Jupiter were any larger, it would actually be qualified as a star. But thankfully, it's small enough where it's just a planet. Now, if you look at the surface of Jupiter here, or the atmosphere, not the surface, but the atmosphere of Jupiter, you can see that you have all these swaths of clouds and belts and zones and whatnot. And this is basically because Jupiter rotates extremely fast. Jupiter's rotation is under 10 hours in time, making it one of the fastest planets in our solar system. And Jupiter, as it rotates very fast, it creates all of these interesting swirls and vortices of clouds, which essentially form all these different belts and zones that you see here in the atmosphere of the planet. Well, this rotation creates some very interesting weather systems on Jupiter's atmosphere. And the largest one is this thing here. This is the Great Red Spot. And the Great Red Spot is a good name for it. It's a Great Red Spot. It's not the most creative name in the universe, but it does its job. So the Great Red Spot is this massive weather system, really, really large. How big? About the size of planet Earth. Now that makes it a very, very large weather system. And what's really interesting is that the very spacecraft that have visited Jupiter have discovered that the Great Red Spot has winds near the edges of the storms. It actually is more of a high pressure system rather than a low pressure system, which is what a tropical cyclone is, the winds in this area can reach up to 400 miles an hour. I mean, imagine being in winds that are 400 miles an hour. Think about the destruction that a hurricane with only 100-mile-an-hour winds can produce here on Earth. Imagine 400. That makes this one of the most powerful weather systems in the solar system. And it's actually been seen by people for 300 years. Back when early astronomers in the 1700s and 1800s were actually observing Jupiter, they noticed the Great Red Spot. So this makes this thing one of the oldest weather systems. Now, we don't know what's happening. We're actually seeing it shrinking a little bit, but we don't know if this is a cycle, if the storm shrinks a little bit, then gets bigger again, or if it's actually fizzling out. We're still trying to monitor the Great Red Spot to figure more about what's going on. And we still really don't know what causes that reddish hue to the Great Red Spot. We're still trying to figure that out as well. But what makes Jupiter really special, even though this is a massive gas planet, what I find to be extremely exciting about this planet are the 79 moons that orbit around this large planet. Now, don't worry, we're not going to talk about 79 moons, but I do want to talk about these moons right here. The one on the far left is Io, and Io is a volcanically active moon. It has more volcanoes per capita than the entire Earth does. And there are volcanic eruptions occurring all the time on the surface. And these volcanoes are just a little bit different than the volcanoes we have here on Earth. These volcanoes spew out molten sulfur, similar to what we see in the hydrosulfur vents down in the bottom of the Earth's oceans. And we think that possibly life could exist on a place like Io. The one next to it, the one on the next, right next to it, is Europa. And Europa is one of my favorite places in the solar system. Why? Because this moon is made up of stuff like Earth, but it also has a lot of water. Yeah, there's actually more water on Europa than the entire Earth. Yeah, it's hard to believe, but it actually contains more water by volume than Earth does, which means that underneath the surface of ice, on the surface of Europa, there's a lot of tidal forces that are happening because of Jupiter. Jupiter's gravity kind of pulls on this moon and causes the moon to heat up. Well, underneath that surface, there could be liquid water. There could be an ocean, a world ocean on Europa. And if that's the case, could there be life underneath the surface of Europa? Now, eventually, there's going to be a mission going to Europa called the Europa Clipper mission that will look for evidence of areas where we could potentially send something underneath the surface of Europa to look for evidence of life. The one right in the kind of in the middle, the largest one, is Ganymede. This is actually the largest moon in the solar system. It's about the same size as Mercury. So if it were going around the sun instead of Jupiter, it would easily be classified as a planet. And the one next to it after that, the last one, the one on the far right, is Callisto, which contains one of the oldest surfaces of any object in the solar system. So Jupiter has a lot of interesting and appealing moons that are actually some places like Europa and Io are, in my opinion, some of the better worlds to explore for the potential of life in our solar system. Now, we're going to go ahead and make our way past Jupiter. Now remember we had before, kind of gave you that one as a freebie, but now it's your turn to think about what the name of the next planet is. All right, I'll give you just a few moments here to think about what comes after Jupiter. Do you have it? All right, well, the answer to this one is Saturn. Yep, Saturn. Saturn, in many opinion, is one of the most beautiful planets in the solar system. That's because if you think of a planet, you probably think of a world that's, a sphere with a ring around it, right? And that's pretty much what Saturn is. But Saturn's rings, as beautiful as they are actually fairly recent, in the last 100 million years or so. So you can see here that the rings of Saturn are made up of, if we were to look at the actual rings close up, which we can't really do right now, but if we can look at them close up, we would actually see that Saturn's rings are made up of tiny little chunks of ice and rock. Really, really, really small, fine particles of ice and rock. They're not solid because they're very transparent. very transparent, and they're highly reflective, which means that they're mostly made up of ices. But there are also pieces of rock too. And we really don't know yet how the rings truly got there. We're still trying to figure it out. One of the ideas is that maybe a smaller planetary body or a small moon got broken up and crushed and basically formed the rings of Saturn. But we're still trying to figure out the mysteries of the rings of Saturn. Now, this right here, this is one of the larger storms in the polar region of Saturn. So Saturn kind of has its own megastorm. And there have been lightning bolts that have come off of the storm that are 9 times the size of Earth. Very, very, very interesting system. And it's also caused by the rapid rotation of Saturn. Saturn actually is the fastest moving planet in the solar system, about 9.5 hours. So remember, Earth has a 24-hour day. Saturn has 9.5-hour days. So you can just see how fast these planets are rotating and create these massive storm systems in its atmosphere. One of my favorite pictures to show people is this one here. If you look at this shot, this was taken by the Cassini spacecraft, and you can actually see this blue dot with an arrow mark on it. Do you have any idea what this could be? Could it be a distant world? Yes, but which one is it? Well, that little blue dot is us. That's Earth, seen from about 800 million miles away. Yeah, so you can see just how small our planet truly is. So, but think about everything in your life comes from that tiny little world seen from this massive planet far, far away. Now, just like Jupiter, Saturn has some really cool moons. Now, Saturn currently right now is the leader of all the moons. It has 83 moons. Yeah, 83 of them. This is one of them here. This is called Enceladus. And just like Europa, Enceladus also has a liquid water underneath the surface. This, on the other hand, though, we've actually seen ice volcanoes spew out from the surface of Enceladus. So not only do we have liquid water underneath there, but we have large geysers, ice geysers, that are shooting up water ice from its surface. And we actually think that much of this ice gets picked up by Saturn and forms the outermost rings of Saturn. Now here we have Titan right here. And now it's not the same Titan that Thanos is from, all right? So if you're a Marvel fan, different Titan. But Titan is a world that could very likely be another indicator for life. In fact, we actually have an atmosphere, one of the only moons in the solar system with an atmosphere. And the atmosphere is very similar to the atmosphere we have found on Earth. Yep, we have actually found an atmosphere very similar to the one we find on Earth in ancient times, before the presence of oxygen. And we also found that on the surface of Titan are these large pools of liquid methane, ethane, hydrocarbons. And we think that life could exist in these liquid hydrocarbon lakes. And we think that just like here on Earth, there are certain life forms that can thrive in these kind of environments. So eventually, NASA wants to send a spacecraft called Dragonfly to Titan and actually fly around like a drone, fly around the surface, pick up some of this liquid and look at it and see if there's any microbes or any traces of the ingredients for life. So pretty soon, maybe in the next 100 years or more, we may have life thriving all over. Just like before, we thought water only existed in places like Earth and stuff. When we learned that water is everywhere in the solar system, pretty soon we could potentially find life all over the solar system. This is a very exciting time for science. Now, the next planet we're going to go visit is the one that always gets the joke, right? Yeah, Uranus. Now, unfortunately, many of us have been saying Uranus for a very, very long time, and a lot of us, I'm sure probably right now, you're already chuckling right now watching this. But Uranus is technically the name, the way we say this planet's name. If you want to get really super technical, it's Uranus. But, you're going to sound really pretentious if you say it that way. And to be quite honest with you, you don't want to be like, look, there's Uranus in the sky. You just don't want to do that. But Uranus is a quite acceptable way of saying it. Now, these planets, Uranus and our next planet after that, are what we call ice giants because they are made up of material that is predominantly what we consider ices. Things like methane, ammonia, water. They're ices in astronomy are stuff that we find in the depths of the solar system, usually frozen. But Uranus is actually kind of a slushy, liquidy, gaseous world. And we think there's actually an icy core, solid icy core near the center of this planet. And Uranus is really peculiar because unlike the other planets in our solar system, Uranus is flipped on its side. It's kind of tilted at a very interesting angle. And it does also contain some rings. And we think that maybe the rings of Uranus could give us a clue to how Uranus got the way it is. We think there could have been a series of planetary collisions that knocked Uranus on its side, and the remnants of those collisions could have been from the thing that made the rings of Uranus. So we're still trying to figure out that. We're trying to get a better idea of Uranus, but we still don't know much about Uranus compared to the other places we visited in our solar system. And the last of the major planets is Neptune. Now, Neptune is the farthest out major planet, and it also, we think that there could be an icy core, or a rockish icy core. It also contains similar types of elements we find here on Earth, with Uranus as well. It's also the windiest planet in the solar system. We think that the core of this planet is still cooling down from its initial formation, and it actually generates these massive winds that can get up to 1,200 miles an hour. But both Uranus and Neptune, we really don't know much about compared to the other worlds in our solar system. We haven't been back since the 1980s. Hopefully in the future, some of us that are watching here today may get inspired to be a scientist or an engineer, and maybe one of your missions is to go back to these large ice giants out there in the depths of the solar system, over almost 1 billion miles away. Actually, Neptune is over 1 billion miles, and Uranus is about 1 billion miles away. And we may discover some really cool, interesting things about these worlds. But interestingly, we do know a little bit more about Neptune. We do know that it does have some high-level kind of icy clouds. So if you actually were to fly through the atmosphere of Neptune, you would actually get bombarded by big balls or big spheres of ice. Very dangerous. You wouldn't want to do that. But there's one of the moons of Neptune called Triton. And it kind of looks like a cantaloupe. But Triton is actually made up of nitrogen ice. It's so cold in the depths of space, over 1 billion miles away from the sun, that ices like nitrogen form. And you even have nitrogen volcanoes around Neptune's moons. So really cool place. But the last place we're going to visit, you're probably already thinking of it, is Pluto. Yeah, Pluto. Pluto is that weird object in our solar system because it actually shares its orbit with Neptune. It's influenced by Neptune. It's really small. It contains 4 other objects that go around it. And it's been a place of scrutiny for almost a decade. See, Pluto used to be a major planet. It was discovered by a man named Clyde Tombaugh in the 1930s. But eventually, in recent times, we've actually discovered planets, or planetary bodies, that are actually further than Pluto and are about the same size. But some of these objects can be 10, 15 billion miles away. Well, this got scientists working on figuring out the definition of a planet. And now, technically, Pluto is what we classify as a dwarf planet. But I'm here in a library. This is actually where I'm at. And let's use an analogy here. So imagine discovering a book years ago that contains some elements of fiction or nonfiction and maybe some elements of some other characteristics. It just doesn't fit in a really defined category. Well, let's say it's the only book you found. And you decide, well, it seems to be more fiction than nonfiction, so we'll just put this in the fiction category for a while. But let's say years later, you discover a whole group of books that contain the exact same characteristics that the first book you discovered years ago. Well, would it be better to take those books and collectively combine them into a new category? Well, that's exactly what scientists did with Pluto. For a long time, Pluto was the only object of its kind further out there until we discovered more, like Eris, Sedna, Haumea, Makemake. And then we decided to group those little objects together and make them dwarf planets. And what makes a dwarf planet is one specific thing. It hasn't cleared its path of orbital debris. It hasn't gotten rid of the stuff that is lurking in the orbits of these planets, of these dwarf planets. Planets like Earth and Mars and Jupiter and Saturn, they've all cleared their path of competing objects. They pretty much got rid of things, either through planetary collisions like Earth did. Actually, 4 billion years ago, Earth got hit by another world and produced our moon. Other planets have done the same, like Uranus, we think. And essentially, all of those orbits are pretty much cleared out. But Pluto has stuff in its orbit. It takes 256 years for Pluto to orbit around the sun, and it just doesn't have enough oomph and speed to get rid of all the other stuff in its orbit. So it has other things flying around in its orbit. So it's the same thing occurs with these other dwarf planets. It actually lies in an area called the Kuiper Belt, leftover space junk in the early parts of our solar system. So believe it or not, Pluto, all it is, so it's all semantics. And actually the word planet has changed over the years. Planets today are basically categorized as their features, like rocky planets, we have gas planets, we have ice planets, we have all kinds of different other planets out there. And Pluto is just one of many categories. Dwarf planets are just one of many categories that we have in our solar system. But don't let this fool you. Pluto is really cool. It has a frozen nitrogen glacier called Sputnik Planum. It has ice mountains, the size of the mountains here on Earth, made up of solid water ice. It has ice volcanoes. It has tar-like material called tholins, which contain the ingredients for life. So you can see that Pluto, even though it's tiny, is a really cool place. And we just barely scratched the surface with our understanding of the solar system. We haven't really talked about all the amazing comets and asteroids and things. It would just take hours and hours and hours to go through it all. So hopefully this program has inspired you to get excited about our solar system and maybe go check out a book at the library about other aspects of our solar systems. There are other solar systems beyond our own. We call them exoplanetary systems. And hopefully this has given you an interest in astronomy so you can continue on and learn more. And you never know, maybe you might become a scientist or engineer, or maybe you have a child or a grandchild that's interested in space, and this has helped them inspire them to get into science. And that's what I'm here for today. I'm passionate about science. I'm happy to come out places like this and inspire not only the next generation, but of people of all ages and all groups to come together and celebrate the wonders of our universe. So I hope that you all enjoyed my presentation today, my virtual presentation of Earth's neighborhood, and we hope to again see you maybe when things get back to normal again. We'll reopen the planetarium and we'll be able to see you there, or we might come out to another library program, or even set up a telescope over here in the Lakeview Park here in Kissimmee. Again, for information about our virtual programs and eventually our regular normal scheduled planetarium shows, all you have to do is visit www.seminolestate.edu/planet and you can find out what's coming up at our planetarium. But until then, thank you so much, everybody. And I hope you have a great rest of the year, and please stay safe, and we'll see you soon. Take care.